Hello, thank you for visiting my talk. My name is Yuriy Senko, and my talk today will be in English. A few words about me. So I'm a team/tech lead at Logica. I have more than 13 years of experience in IT, and I'm a Pythonista for last 10 years. So that means that I spent like most of my professional life writing Python applications. And my today talk will be about kind of success story of replacing the horrible legacy application with Apache Airflow. Does anyone know what Airflow is? Good, good. Okay, and in my talk, I'm not gonna like retell the official Airflow documentation, and we'll try to emphasize on practical experience using Airflow in production. So in the first part of the presentation, I will explain the problem that we had and kind of will try to give an overview of why we choose Airflow, and the second part of the presentation will be mostly about the practical usage and production deployment monitoring and stuff like that. So let's go. Some time ago, like 2 years ago or so, my team and I got an easy problem. So we got a horrible legacy ETL system. Do you know what ETL is? So ETL is the type of application that does some data processing, and ETL stands for extract, transform, and load. You extract some data, you transform them, and you load them back. It's used mostly for reporting-like systems. So as I said, we got a we got a legacy ETL system, and the system was partially done in Python, like some Python microservices talking to each other using RabbitMQ, and there was some logic written in bash scripts and shell scripts, and there was a piece of logic which sitting in the database, so stored procedures, and so on and so on. And all of these stuff were mixed together, and that was horrible. Also, the test coverage was not great. It was pretty low, and that was making the support and development of this application like not very easy. There was no good monitoring, so the support team had a hard times tracking problems and trying to resolve them. This small diagram, like this simplified diagram, shows how the system was built. So everything was ruled by a cron daemon, and the cron was kicking off scripts here and there, like Python scripts, shell scripts, to start some processing. And these services, like Python and shell bash services, were able to call each other for the next to continue the processing, like, and do some next steps. And eventually, one of the services was pushing the data into the database, where the database logic kicks in and finishes the processing and actually stores the data in some kind of storage. Usually, it was Oracle or Postgre. So that's a short description of the problem. And now we have got some requirements. So our goals was to refactor the system to make it reliable and scalable. As I said, the system was highly unreliable, and the support team was spending hours and hours and hours fixing user bugs. Also, we had, since the system was done and the code was there, the product owners was not very happy about rewriting the system, so they asked it to make just minimal possible changes to make the system more reliable. And they also asked it to make the system like easy for use even for non-programmers, like the L1 support and so. And also we have added one more from our side, as a monitoring and centralized logging are highly desirable, just to make sure we can easily debug and support our system. Okay, so we start investigating the problem with the old system, and we have found like several main weak spots within that system. And the first one was cron. So what is wrong with cron? First of all, cron is very hard to monitor, and that's because the usual approach of monitoring cron jobs involves sending an automatic emails, and usually you probably don't want like humans sitting in the middle of the night and reading the automatically generated emails, right? So that was not a very good technique. And imagine that you was able to identify that a problem occurred in your system, and now you need to somehow react to it, probably fix it. And usually if you have like a bash scripts and cron involved into your system, the usual way to fix it is probably to log into the system, to find some logs on that host, and to rerun the shell script manually with the like fixed parameters, and rerun the shell script manually. And that is pretty dangerous, I would say, because humans often make mistakes, especially under the pressure, when the highly important job on the production server fails and the customer do not see any data in his report. And finally, the cron is pretty hard to debug and support because you have to manage a cron, like cron tab, and you have to update cron configuration randomly during deploy. And eventually someone might actually change something directly in the cron tab file on the server, as something will not process in time, and that can cause like other problems that are very hard to track. And cron hard to scale because it usually operates within one server, and it's very hard to scale this approach horizontally. And next weak spot that we identified was basically bash scripts. They share the same pain points with cron, so they are hard to monitor. Usually you will be sending some automatically generated emails in case of some problems, and someone must read all this stuff. Also it's hard to develop and maintain, because have you tried to write a unit test for bash scripts? Oh, good. So it's not an easy. We have found an application and a library which allows to do that, but that was a nightmare. And there was actually another problem. There was too many of them. Like I would say 20 to 30% of the system were implemented in bash. So it's so we started thinking about an option, and probably the first and most natural thought that we had is to let's rewrite everything with Celery. So it would be nice. We will implement everything in Celery, and I would say, and when I say implement everything in Celery, I mean we will try to reuse Python code from the legacy application, and we will have to rewrite bash in Python. And it was like, we will spend a lot of time doing this. So we started looking for other solutions. And eventually we have found two more platform or frameworks. One of them was Luigi. Implemented by Spotify and open sourced. It allows you to build automated workflows. And there is its competitor Airflow implemented by Airbnb, and it allows to do the same thing basically. It allows to build dynamically build a computation workflow. Like we had a talk about Celery, and the presenter said that it's sometimes hard to chain Celery tasks together to make them do some bigger job instead of some atomic job. So these things allows you to do that. So as I said, we got like the three options, and we started looking for a way to compare them, because we wanted to use something that fit our needs well. And we identified several criteria that were highly important to us. Like we definitely wanted a web-based dashboard to manage and monitor our workflows, so the support team can, instead of reading automatically generated emails or logging over the SSH onto the box and trying to check logs, the support team will be able to open their browser and see, hey, there is a problem, let's restart this. So for custom Celery solution, there is no such dashboard, and you need to implement this. Luigi, it was a disappointment for us that Luigi has a dashboard, but it's very limited. It's kind of allow you to see the your pipeline, but it won't allow you to manage it, to restart something, to see how it is going. And the Airflow dashboard was awesome. We also wanted to get rid of cron, so one of the features we wanted was built-in scheduling system. And unfortunately, Luigi has no scheduler. The documentation says use cron. So yeah, Celery has a scheduler, Airflow has a scheduler. We also wanted to be able to backfill information, and we wanted to be able to see the history of our pipeline's execution to track the progress. As I said, we also wanted the scalability, and we wanted the system to be easy to extend. And the final, but probably also important, is to have at least basic alerts built into the system. So you will see a red flag with when something is wrong with your system in production. And as you see, like Airflow has much more green on it than Luigi and Celery, so we decided to give it a try. And clickers, yeah. And actually, our confidence even increased when we found that the Softworks Technology Radar recommended to trial the Airflow for building dynamic computation pipelines. So we started our MVP work, and we have found like that Airflow also provides additional benefits that we can leverage. Like everything in Airflow is a code, and even like the scheduler configuration, your schedule is a code. That means that you can test your production schedule. Also, Airflow allows you to run almost any code, like Python, Bash, Java, Docker, everything you can run from almost everything you can run from the Unix command line you can run as like inside the Airflow. Also, in addition to a web dashboard, Airflow provides a rich CLI interface with the same capabilities, and probably even more, that actually allows you to automate some things. And additionally, all logs are available through all Airflow logs are available through the web dashboard, and that means that we are getting the centralized logging almost for free. And also, Airflow provides a like very simple resource management system that allow you to like set priorities for your tasks and limit parallelism. So let's very quickly, like in 2 slides, go through the Airflow concepts, just to have like for those of you who has no experience with Airflow, just to give a basic understanding of what it does. And Airflow operates with the term DAG. DAG is a directed acyclic graph, and basically this is your execution pipeline. This is what you want to do. And DAG consists of tasks, and a task is just some Airflow operator, call it, with some parameters. And out of the box, Airflow provides like a huge variety of operators, like a bash operator that allow you to call a bash function, for example, or bash command, a Python operator that allow you to write an arbitrary Python function, a branch operator allow you to make a decision, like an if operator in Python, an HTTP operator to interact with third-party APIs over the HTTP protocol. Sensor operator allows you to wait for some event before you can continue processing the data. Docker operator allows to run a Docker container, and many more. Also, there is a huge set of community-supported Airflow operators, like including operators for to integrate with the Hadoop ecosystems, integrate with different databases like Oracle, Postgres, MySQL, MS SQL, and a lot more. And operators that allows integration with cloud services like Google Cloud or Amazon Cloud. And on the right side, you see an example of a very simple DAG. So first 3 operators are like bash operators that call curl commands to talk to external API. And the final operator just loads the data downloaded by this curl command into the database. And by the way, this is a screenshot from Airflow. Airflow adds a green boundary to the tasks that completed successfully, and red boundary to the tasks that are failed, and yellow to some other tasks we'll see later. So here is the internal structure of the Airflow. So one of the main components is actually web server and web application, which provides the dashboard functionality. It's written in Flask and Flask admin. And that's a regular Flask application. Also, the scheduler is the separate Python process, and scheduler is responsible for scheduling your pipelines and executing them in time. Also, Airflow requires a database to store configuration, to store some metadata about your pipelines, and you actually can use almost any relational database in case it's supported by SQL Alchemy, because Airflow uses SQL Alchemy to work with the database. And the final part that you have to provide is a cluster of executors which will be running your pipelines. And for executors, the recent version of Airflow supports 3 executors backend. This can be a simple Celery backend. This can be Apache Mesos or Dusk. And actually, they added Dusk recently, because when we started 2 years ago, there was only Celery and Mesos. Okay, that's was an Airflow concept. Let's see the Airflow from the more practical side. And first of all, DEX. Airflow says DEX are dynamic, but it's not completely true, because the way Airflow generates your DEX is that it iterates over the Python files in the DEX directory provided and in config, and it is looking for an instances of DEX class in the global namespace of each file. And that means that your DEX actually needs to be pre-built on that import stage. So when Airflow imports your file, it expects to find all the DEX already there, build and set, and you cannot change them in runtime. So we had to invent a mechanism which allowed us to actually be more flexible here. So we I would say invent, but we did not. So it's we introduced a function that returns a iterator that provides us with a configuration for every doc. So we just iterate over the configuration, and we have a factory function that builds a DEX out of configuration for us. And then we just inject everything in the global namespace, so Airflow see all the DEX that from our configuration. It's a very dumb and simple approach, but it works well for us. Another important thing is a DAG name. So DAG name is a unique identifier of a DAG. So there can be no 2 DAGs with the similar names in the Airflow at the same moment of time. And also, since DAGs should be unique and should uniquely represent the DAG, so the DAG name should change when you change your DAG. For example, you changed a schedule for your DAG, and it would be better to change the DAG name as well. First of all, it's easy to work with DAGs from the dashboard with that approach, and the second reason for that is because Airflow, sometimes it has some problems, and it might not find that you have just updated your DAG and it needs to repopulate a DAG, DAG code within your cluster. So we applied a similar approach, and we built a function that builds a unique and reproducible DAG name using the DAG configuration. So it's very simple. And here is a DAG name pattern that works more or less well for us. Since we are mostly working with the external advertising platforms that provides us with the data like AdWords, DS3, DCM, a lot of Google services, Facebook, and so on, we decided that we must have the external data provider as a part of the DAG name. So, for example, in this example, it's AdWords. And the next component is the report type that we are processing, like the type of CSV or JSON file. For example, here is, I put performance because we are processing a performance report with clicks, impressions, spend, and so on and so on. It can be like campaign, advertiser, a lot of them. And the final component is a schedule name in a human readable format. So if you change a schedule for this doc, this part of the name will be regenerated dynamically, and it will be a completely new deck for Airflow, and it will forget about an old deck. It will still be sitting in the configuration, but it will be marked as deleted. And another benefit of having a structured deck names is that you can very easily work with the DEX dashboard. And for example, when the support team is interested to see how conversions data are processed, they can just type conversion to the search, and the decks that are processing conversion data will be shown on that page. And by the way, on the last row, you see how Airflow marks the decks that are failed due to some reason. And if you click here, you will see the detailed deck page, and you will be able to see the logs, restart the deck, and do many more things. It started working again. Okay, next important thing that every ETL system is scheduling and backfill. And first of all, I would suggest to always use UTC, always. If you use something else, some other time zone, you will have a big problem. So for scheduling, you need to build your deck schedule very carefully to make sure you are not running everything at the same time, because you obviously will have a problem when tons of your decks will kick in at the same time and will try to acquire some resources to do a computation. Also, building that schedule, you might actually be interested in running your deck to figure out what time it takes to usually run the deck, to have all the data ready before you need them. And actually, Airflow provides you with a dashboard that allows you to see how long, in a historical way, how long it takes to run your deck on a daily basis. Every DAG in Airflow has two important properties. The schedule interval, which basically a cron-like syntax that defines a schedule for your DAG. For example, if you want to run your DAG every day 2 minutes past 9 AM, you will use something like this. And the start date. And start date effectively defines a date when your DAG effectively becomes active. And it's a good practice to align the schedule interval with the start date to avoid I needed or missed runs during the first iteration, because that's a kind of bit of problematic part of Airflow schedule, but they have an issue related to this in their tracker, but it's not important, so they don't want to fix it as quickly as possible. And how about backfilling? Imagine that you have to put into production a very important data processing pipeline, and you have to have a data starting from May 1st, right? But we all want to visit the PyCon in Kharkiv, and probably we want to spend May 1st and 2nd with our family and friends. So there are two options. You can overtime here and release your DAG a bit earlier, or you can still release your DAG after you get back to work and just set a start date to May 1st. And Airflow will take care about backfilling itself. So it will run your DAG, your pipeline, for all the missing execution dates between the time you release it into production and the start date that you specified for the DAG. So it's very cool thing, by the way. Okay, next thing, it's probably not so directly related to the Airflow development. It's just a common sense, a common concept in the programming. So you have to keep your tasks as independent as possible, and it would be better to keep them idempotent. Because imagine the almost same example of DAG that I showed earlier. So this DAG basically queries the some advertising API, which uses CQRS. So does any of you familiar with a CQRS pattern? Okay, cool. So I'll explain in 2 words. CQRS effectively means that You make one request and say, hey, API, please build me that report. And API returns you some identifier of the report and start building the file, because it might take some long time. Then you periodically say, hey, API, here's the ID of the report. Is it ready for download or no? API says no. You get back in like 1 minute and asking again. And once API reports that the data are ready, you can download them. Right, so here, that's what 3 tasks at the top are doing. Creating and running the report, waiting for file to be ready, downloading it, and do some other processing in the end. In that case, this task which waits for file failed, because API returned, for example, file 4 because of the huge load. So what you probably want to do is you want to retry your task, right? But in this case, it's very simple. You just retry your task from there, and Airflow will run all the missing tasks automatically. Like, these 2 tasks are skipped because they depend on this failed task, so Airflow marked them with yellow and skipped them. But imagine that you was lazy, and you, instead of separating this task for creation and downloading report into 3 stages, you implement them as a whole thing, right? There is only one task to build, wait for file, and download the report. If it fails somewhere in the middle, you will restart all the data processing pipeline from the very beginning, and you will spend like additional time on rerunning things that are already done. In that case, report is already built, and we just need to wait for it. So just keep task idempotent and independent. Also, at some point of time, you will need to store the intermediate results of your task, or even the result of the whole pipeline. So the the first intention is to use a local file system in the cluster. But remember that Airflow, in Airflow, the next task will probably be executed on a different node VM or even data center. So, and will not have access to that file. So the general recommendation is to use some third-party storages for this, like Google Cloud or Amazon S3 buckets, network file system, or some external database. Just pick the storage which suits your needs most and use it. Okay, next thing is about logs. It's also not directly related to Airflow, as far as related to all the good practices that we use in programming. So make sure your log messages are informative. So instead of just putting a cryptic Python traceback in logs and like have the support team scratching their heads and asking you like every 5 minutes, hey, what does traceback means? What should I do with this? Instead of this, put a human-readable description of the error. And also, you can put like some next steps that you recommend to perform in order to fix that problem. If the API returned a file 4 code, recommend to retry in a few minutes or an hour or so. Just like think about this. So think about this. If you will need to read these logs in like 3 years' time, whether they will be useful for you or not, will you understand what was your intention when you like just added this log message? Okay, retries. Airflow provides you with a retries out of the box. So do not invent your own retries system. Just log a human-readable error and just re-raise an exception. Everything that is not catched will be retried by Airflow automatically, and by default, Airflow provides 5 retries, but this can be configured through the Airflow configuration. Okay, as I said, Airflow also provides a simple resource management system that allows you to load balance your cluster. And in that case, I'm going to show like the pools mechanism. And pools is very similar concept to what we have like in, for example, multi-processing pool, when you say that some task has only, for example, 2 slots to run. And that means that only 2 instances of that task will be able to run at the same moment of time. And we had a problem with one of the external APIs. We had a very bad performance with it, and it turned out that the API actually rate limiting us because we are making too many requests. So we set up a pool and we limited the concurrency for that task, and we got much better performance. And interesting thing about like things like pool and some other Airflow entities is that you can create them like in two ways. For example, to create a pool, you can go into the admin menu, then select a pool from the drop-down menu, click on create button, and create a pool you need with the configuration you need. However, it's not what you want, because if your DAG rely on the pool or like some other entity and you forget to add it after you release your functionality into production, that means that your processing pipeline will most probably fail in the middle of the night, and you will have to jump on the motorcycle, go to the office, and fix the problem. But you can do different thing. You can create a very simple Python script, let's say just a plain script, or use click, and you can basically add the pool automatically. Like the pool is actually a SQL Alchemy model imported from Airflow package here. So just create as you usually do with the data migration, create an instance, commit it to the database, and have your pool ready. We are running such scripts before we do a release into production. So first we insert an entities that on which our system rely on, and then we add a new DEX into the system. I also mentioned about the shell scripts, and it was a nightmare for us. So here is what we did with the shell scripts. We built a Docker image that contained all the requirements needed for our bash scripts, right? And then we used an Airflow operator to run our bash scripts inside the Docker container. So we effectively used a Docker operator. And that allows us to scale shell scripts automatically. And as a benefit, we got all the logs from bash scripts in the Airflow dashboards. The good story about that we already decommissioned bash from our system, so we don't have bash anymore. But that was a way to solve this problem, and it worked for us for some small period of time. About security, at some point of time you will probably want to limit an access to your dashboard, or even want to limit an access to some of your decks, some of your pipelines. And Airflow provides you a few integrations out of the box. First one is a simple password authentication, which can be enabled automatically. Next one is integration with a corporate LDAP, and that's what we use in production. It works fine. Or Kerberos. You can also use integration with OAuth providers like Google Authentication, or roll over your authentication module by extending a Flask login. But building, like writing the code, is only half of the problem. Another half of the problem is to actually make sure your code works fine, build some artifacts from your code, and deploy into production, and also like monitor that your production runs smoothly. That is why we built a CI/CD pipeline for the Airflow. So a bit like the tool that we are using GitHub to manage our source code. We're using Docker to run Airflow both in local development environment and in production. We use Jenkins as our primary CI/CD tool. We have unit tests. We're also using a BDD technique to test our pipeline's business logic and schedule. I'll talk about this a bit later. And we use Kubernetes to run the production version of the Airflow. So let's quickly go through the circle. So as I said, for development environment, we use Docker, and the Kubernetes was not a part of Docker for Mac or Docker installation like 2 years ago, and Minikube was a bit like not what we wanted. So we are using Docker Compose to develop DEX. And here are the services that we have in Docker Compose. We have a web server serving the web dashboard. We have a scheduler service running. We have a Postgre running. And we have a tiny, in dev environment, we have a tiny Celery cluster with one worker just to test our pipelines. About the testing, we extensively unit test every task in the DAG. And we also have use a BDD, behavioral-driven development technique, to describe logic of every business logic of every pipeline, of every DAG, because we think that it's very important that product people can actually read what your pipeline does. It's basically a Gherkin language, like given, then, and it's very similar to English language. And we also, BDD our schedule, because I said schedule is very important for us, and it's important that this task must run at 9 a.m. and not like 3 p.m. And here is the simple example of BDD scenario that checks our schedule before putting into production. Like, given admin user logged into the system, admin checks scheduling configuration, a schedule should be, and then this is exactly the schedule of our report. Like, for account 1, add the mentioned report needs to be run at 7 a.m. every morning, starting from February 19, 2016. So it's very simple. We have like the scenario that checks all the schedule for our Airflow decks. And if someone wants to change the schedule, he should change the test first and ask for review to make sure that this schedule change is intentional and not by mistake. We also use Kubernetes in production, and we are using Google Container Engine, which is a fully managed Kubernetes deployment from Google. It shows very good results in the production, and basically they are not charging for master node, so it's cheaper than keeping your own Kubernetes cluster in, for example, Amazon. We also use built-in support for logging and monitoring using Google Stack Drive, and it's very easy to set up such cluster just to try for yourself in a few clicks from the Google Developer Console, or if you want like a reproducible environment, as we did, you can use like some kind of infrastructure as a code, for example, Terraform, to create your cluster automatically. Here is the layout of our Kubernetes cluster. So as you can see, it's almost the same as we use for development. So we have a web service with one replica, we have a scheduler service with one replica, we have a Postgre database service with single replica. There is master and slave and 2 slaves. We have worker service with 8 or more replicas, and we have persistent logs volume and persistent Postgre data volume. So as I said, the layout is the same except of different number of salary nodes. Monitoring. For infrastructure monitoring, we are using Google Stack Driver, basic Google Stack Driver monitoring, and it allows us to check the services availability, CPU and RAM usage, the usage of logs and PostgreSQL data volumes. And probably, in addition to infrastructure monitoring, you will want to introduce something like for application level monitoring to make sure that your business logic is running in production smoothly and without any problems. Before doing that, you have to consider like these cases. First of all, in addition to just monitoring, you probably want to configure alerting, because having just a dashboard which shows red and green flags is not enough, because you need to make sure that someone is opening that dashboard from time to time. So consider configuring automatic alerts. You can do this with both Airflow or add your own solution. We are using integrated with Zabbix in that case. And you also need to make sure someone is responsible to reacting to these alerts, because if you have a Slack room with 25 people and the alert comes into that Slack chat and no one reacts to this probably something is wrong with your monitoring. And you actually probably want to monitor as much things as you can, because there is no such things as too much monitoring. Here is the bare minimum that we have for our Airflow installation. So first of all, we have extensive scheduler service monitoring to make sure it's always alive and it sends a heartbeat. Because there was some race conditions in the older version of Airflow where the scheduler can just hang on some edge case and the service is available, but it does nothing. So we just we found this problem in our production, we fixed it, and we decided to put monitoring on it in order to make sure that we are not repeating the same mistake twice. We also have an alerting about failed decks, and here, as you can see, an example of Slack message that says that 2 decks were failed. and someone is reacting to this. Usually that's a support team. We also recommend to monitor all the external services you depend on. For example, if you need a VPN, a network file system, or external database, just monitor that it's available, and otherwise your DAGs will be failing for with the strange error messages. And we recommend to use, as I said, we recommend to use evolutionary approach to monitoring. So at a bare minimum, which is working for you, and then track the problems. If you spot the problem, just fix it and monitor it. And as a conclusion, we run Airflow in our production for almost 2 years. We run more than 100 DAGs of different complexity every day, and the amount of the support tickets decreased to a very minimum. As far as I remember, there was 3 or 4 during 2017 when the support team was not able to handle the problem themselves, and they asked to help them with this. So I actually think that we achieved our goals that I mentioned at the beginning of the presentation. Thank you for attending. Any questions?
I have 2 questions actually. First, you said there is no need to implement retries because Airflow can do this for you. So the question is, what is the overhead of Airflow doing retries instead of you, when you can simply implement retrying HTTP request every second? And the second question is, do parts of DAG pass some data, in direction of DAG? Mm-hmm. Or does this make them dependent on each other? And it's stupid question. Yeah, thanks.
Okay, thanks. The first question was about retries. What is the overhead of the built-in retry capability? And I would say that there is no overhead because you do nothing about that. That's no overhead from the implementation point of view. From the looking at what is the computational overhead, I would say that it's a similar retry that you will implement yourself. So something have failed, Airflow wait for some backoff interval, and then run this task automatically again. So the approach is the same. It's just very much easier, and the code much cleaner than implementing retries yourself. However, if some libraries, for example URL lib3 or request, already provide the retry for you, that's also fine. You can use both. Just remember, for example, if the database is not accessible and you want to write into the database and your task fails for the first time because database is not yet ready or there is a network partitioning somewhere, so Airflow will retry this automatically, and you do not need to handle this reconnect by yourself. Just let it fail, and Airflow will restart the task after some period of time. And I forgot the next question. What? Okay, yeah. So I had a slide, but I've removed it because the presentation was a bit long. So Airflow provides you with a way to communicate between the tasks. By default, they are independent, and Airflow does not pass any information. But you actually have 2 variants to communicate between tasks if you need, built-in into Airflow. First of all are variables. Variables is something global, pools. You configure variable through the admin menu somewhere. There, I don't have a screenshot of that. So you go here, you choose variables, and you create a variable. This is just a record in the database, and you can read it from any tasks. They are global. And also Airflow provides a tool called XCOM, which stands for cross communication. And it allows some task to pass a message to any downstream jobs. For example, this task, in our case, that's a typical pattern for our DAGs. DAGs that don't load the report file, stores it somewhere. They just pass to the file, for example, a Google Cloud Storage bucket URI, to the following tasks. And the following task can read this message and read the file location. To implement XCOM implementation is very simple. Everything you return from task treated as an XCOM by default. And you can just return a string with the path to the file. Airflow will remember it. And in this task, you will say, give me an XCOM from task name from task with that name, and you immediately can read this this value and process. So also you can use like some integration storages like Redis, Postgre, whatever you want to actually. But the good thing about XCOM is that you have a single DAG which can run like every minute, every 5 minutes, every day, and that's basically a single task, a single DAG with the same name. But the task runs are different. For example, the task runs today and tomorrow they can be different because the one task can finish with error because file is not available or something. And XCOM provides you don't need to care about like putting the date time or whatever to like uniquely identify your DAG run. XCOM like handles this for you. It will be unique in scope of this exact DAG run. Did I answer your question? Okay.
So we have an asset management system that has information about all the hardware, like so everything in the data center and in the back office, and we do use that for sending periodic notifications regarding to the depreciation of equipment, let's say. And right now we do it with cron, and we go to some data. We run a script from the cron that goes to the database, scans for the depreciated equipment, and then sends the email notifications for the technical owners of the equipment that is going to be depreciated in some time, so they can take further actions. And as far as I understand, we can replace those crons with this Airflow. And I think, well, we do manage those crons with Puppet, and while Puppet manifests themselves are really easy to test, it's really hard to monitor whether or not the scripts themselves are running and the notifications are coming out of the database. So is there a way we can do what, we can send these notifications from Airflow, I mean run those tasks, but without managing those tasks in Airflow manually, but by integrating with existing configuration management system, which is Puppet right now for us?
So you definitely want to do almost like, no, it's a lie that you want to do almost anything in the Airflow, but you definitely can implement your pipeline. It's very easy. It's just every Python task is just a Python function, and you chain them together. Say, hey, Airflow, run this task after this task finishes, or do some if. There is also a way to use to integrate with other systems, like and kick off DAGs like dynamically. For example, you can have a DAG that waits for some event, like, and if event arrives, it kicks off another DAG that is able to process that event. So it might be the case for you. I'm not sure about like exact integration with Puppet system, but you definitely you basically have a base operator in Airflow which you can extend in any way you want, like by redefining the run method and inject this operator in Airflow. So I would say you should give it a try. If you want, we can talk like after the presentation, and you can explain me more about this.
Thanks for an awesome talk. It's more of a remark than a question, perhaps for those who decide they are for using Airflow. You should actually be really careful with retries. You speak about the ETL, right? And so you load data in the end. And sometimes, for example, you're saving, in our case, we were saving data into Parquet files. And the task may fail after this. After the data has been saved into HDFS. And actually, instead of 5 million rows, the retry count is 5 times, and well, actually, you result with 25 million rows. And so you should really be careful about retries when the tasks are not idempotent. Thanks.
Yeah. That's completely true. So there is no silver bullet. Everything has its own price, and like you need to treat each case like separately.
More questions?
Thank you.
Thank you.